So SAE has two primary facilities, let's say, where the teams do their work. So there's the cage, which is located in the basement of the hall building. Um, it's basically a super gigantic garage where the vehicles can be stored, where there's a work area with a bunch of new computers. We have a server room. We have a welding spot. Like it's really, really, really big to accommodate for all these large scale projects. You might have seen it if you went for a tour of the Concordia University. Um, and then there's the Bianix building. The Bianix building is also where ENS Games, IEEE, so like the vast majority of the ECA societies are located. And that's where we also have a bunch of computers and servers, and it's also a design area, and that's also where aero design is based because well, we can play with wood in the cage, let's just say, because of fire hazard. And also, yeah, as Will said, a lot of our members, like currently, I think we have two of our members who are at Tesla this summer. Like by participating to these competitions, you really do get to network. For example, for aero design, we had to do our design presentation in front of a bunch of vice presidents from Lockheed Martin. So it's really you really get to meet people from the industry. Yeah, I think I can stop. Sorry. Yeah.
All right, so I'll start sharing my screen now.
Yep, go for it.
Yeah, thanks for the introduction, guys. Great. Right, I'll start. So, hi everyone, my name's Phil. I'm the aero coordinator for this year. I'm going to be talking about aero design and more specifically how the design process works. So, how do we start from an idea to a finished product? So that's going to give you a really good overview of what we do in the society. So let's start. Yeah, so this is basically the step we're going through. I'm going to discuss all of them briefly. And yeah, this is for us the bit of timeline, so you get a bit of an idea. About half the year is spent designing it, the other half building it, and then there's comp at the end. So the first step in any project, so when the rules that SAE International, when they come out, the first step we have to go through is to understand the rules, understand the scoring, how to make the best possible airplane. So yeah, understanding the rules, that's the first step. The second step, that's very specific to aero. We start designing the airplane, but at this point we don't have any math yet, so we're just choosing our basic configuration based on a few parameters, and this is all like theoretical, lots of assumptions. So yeah, there's a lot of reading involved. You have to have a lot of knowledge to have some good idea of what you're doing at this point. And then we go through initial sizing. That's also a step where that's unique to aero. Like every single plane that's being designed right now will go through initial sizing. They all go through a constraint diagram. And yeah, every plane you'll design, if you're an aero student in your classes, you'll have to go through this. So it's great you learn it in aero design in the SAE Society. And yeah, even in the industry, like everybody uses those. And so they're really, yeah, again, specific to aero. And then we start getting to the real math and really start designing the plane. So from there, we start designing the CAD, so using SolidWorks, and they're doing some basic FEA analysis and some basic aerodynamic analysis is really crucial in for aero design. The aerodynamic analysis compared to the other car societies, and yeah, Venn diagram. This is also a thing that's specific to aero. So this is the step where you start really designing your aircraft. And yeah, detailed design. So preliminary design and detailed design, those are the two steps that I think every society goes through. Those are the main, we're spending most of their time on these. And then detailed design, at the end of that step, we should be having a completely finished product. Um, I mean, the CAD should be really, really detailed, so much that someone who has never heard of the project would just look at the CAD and be able to build it. So the FEA analysis should be really, really precise as well. Make sure that we remove as much weight as possible and just have the the material right where we need it and no extra material. So is in aircrafts, like weight is such a critical component. So we try to remove as much weight as possible while keeping the structure strong enough. And yeah, the aerodynamic analysis is really complex as well. So not just predicting like how much you'll be able to lift, but also how your plane will handle once it's in the air and how it will react to wind gusts, and will it be like stable under all conditions. So those are things we're working on, and it's really important to to watch the weight. So it forces communication between all the teams. That's really interesting, and because your center of gravity will affect a lot of parameters in your aircraft. So yeah, and then once the plane is completely designed, we start manufacturing. So the first step is to get the SolidWorks CAD and to make drawings out of those, get them approved by our EIR. The EIR, by the way, is the engineering in residence. So it's the person from the school that has a lot of experience, which oversees the whole project in the team. And yeah, so we're working a lot with our EIR. Every team does. And yeah, so he approves the drawing, and then we can start manufacturing. So some of the stuff we're manufacturing in EDML, like Will said. Other things like the foam wings you see here is just in-house manufacturing, and some of the stuff we just order and we just use as is. Uh, yeah, so manufacturing takes a lot of time, and then we have assembly, which take a lot less time, but it's taking all those components that we have and putting them together. So that can be really complex as well, and you'll face many challenges that you haven't thought of, even though like your CAD was really well defined. And yeah, that's also when we implement all the systems components. So when we refer to systems in aircraft, it means all the electrical components. So it's going to be like the motor, it's going to be batteries, all the wiring, servo motors to make all the control surfaces move, so the ailerons, the rudder. And then we get to testing. So testing, we can do a bit of testing in Montreal. Like we can do prop testing to choose the exact right one, the most efficient one that gives most thrust. And then we get do systems testing once the assembly is done, to make sure that if we go to controller and put joystick to the left, then the plane will react accordingly. And so all of that is done in Montreal before we leave. But since our competition is early March, as Will said, we can't really test our plane outside like in February. That doesn't make sense. So we have to wait until we're at competition. So competitions in the south of the US, it's either Florida or Texas or California. And yeah, so we have to wait still till we're down there to do some testing. So with all the assumptions we've made on the plane throughout the design, because you can't know everything, yeah, this is a stressful moment. So we usually arrive a few days early at comp to test down there with the pilot. And yeah, so we drive down there with 15, 20 members, depending on the year. We rent a huge house. Comp is super fun. We don't get much sleep, but it's part of the fun. It's super intense, and yeah, we see our plane fly for the first time, and the thing you spent like 8 months designing, and you actually see it fly. That's the best feeling in the world. And yeah, it's just beautiful to see. So comp is divided into, you have the tech inspection. That's one day where you do your presentation in front of the judges. That's super important. And then you have tech inspection. So they inspect your plane, make sure it it follows the rules of the competition, and also it's safe, you know, because you have a huge battery. There's a lot of juice in there, so it can be like really problematic if your plane starts bursting into flame in the middle of your flying rounds. And yeah, and then you get to flying. So you get 2 days of just flying rounds where you just complete the mission. So the mission for regular class this year is to carry, like, take off within 100 feet and carry as many soccer balls and the metal plates as possible. So like they're weighed differently, and the more you carry, the more you score. But you're limited in the power for your motor, and you're limited in wingspan. So it becomes a real challenge. And you might think, oh, if you're smooth to this one, this is the flight path. So it's just taking off, going around, and then landing. And you might think, oh, that's not really hard. But out of 30 teams in the first day, like 9 of them crashed. So it's not really straightforward. There's yeah, some days there's a lot of gust wind, and yeah, there's crosswind. It's a mess. But yeah, we managed to do great. Last year, we came out we got a good score, so we're really happy about that. And then the advanced class is a whole nother project. So it's usually a capstone team that does it because it requires so much more work, and it's basically a more intense design process in regarding the systems. It's much more complicated. They have to drop some specific payload on some specific areas, and they all have to, like, the plane has to know where it's at, and once the plane recognizes it's in a certain area, then drop the specific payload. So it's pretty complicated. And right, so that's the two teams we have in Aero this year. And yeah, the advantages of Aero. So one thing we do compared to other teams is that we redesign the plane every year. Like, we have to, it's in the rules, we have to build a new one. And even though the rules change every 3 years, we have to build a new one. And so because we're a team are relatively smaller, although this year we have quite a lot of members, there's like every member has a lot of weight in the design because yeah, the team is small and there's a lot of work. And so you can see the whole process of designing a plane every year. So it's not just like, oh, this year we can only do suspension. So if you remember, you only see suspension for a year. Well, that's not the case in Aero. You see the whole design process every year. Also, yeah, it's a multidisciplinary project. So we have not only Aero and mech students, obviously, but we have a lot of ELEC and CON people for our systems components. So it's really interesting to see like different aspects of an engineering project. It's really realistic in the sense that you're working with different teams that have like different point of view, and sometimes what you think is best would be best for aerodynamics. It's not best for structures or systems. It compromises them. So it's always like arguing with what is the best solution, finding the best solution. So yeah, also if you're really interested in working in the aerospace industry later, you have a lot of networking opportunities. So with students, you'll meet a lot of students who are passionate about aerospace. It's really cool. You'll probably get to meet professors who are in that field because we ask them questions all the time. We're also sponsored by a lot of people. There are companies in the aerospace industry. It's really cool. And yeah, as Sev mentioned, the judges at competition, they're from Lockheed Martin last year, so that's really great. We can get some good contact there, and we get some internships. And yeah, especially this year, we're going to do a lot of research. So because of COVID, we don't even know if we're going to have a competition. So we're doing, we're still building a plane and going as if there was no COVID. But if it happens in Campus Cancel, we're going to do a lot of research this year. So we have a lot of interesting ideas, and we can get to optimize the design process even more. So yeah, as I mentioned, the team is divided in three. So it's structures, systems, and aerodynamics. So we don't have just aero students, but also co-ed and mech and elec.